All right, let's do another exponential word problem. Let's look at page 20, number 4. Before we start that problem, I'm just going to refresh your memory on how to solve for a variable that is stuck in the exponent. All right, so in order to solve for a variable that's stuck in the exponent, we have to do one of two things. We have to either try to make the bases the same, and if we can't make the bases the same, then we have to introduce a log, because a log allows you to release the exponent. So there's no way for me to rewrite, or no easy way for me to rewrite 6 with a base of 2. So I'm going to use a log to solve this. I'm using the log because I need to release the exponent. When I write the word log in front of the 6t, the log is the key that unlocks the exponent and allows the exponent to jump in front. I put the log on the right side, so I have to put the log on the left side because I need to keep the equation balanced. All right, so after I introduce the word log, the t drops in front, and then this is just t times log of 6. So to take that off, I divide off the log of 6. Then I can use my calculator to evaluate this because my variable is by itself. So alpha y equals log of 2 over log of 6. And then these questions would tell you to round to a certain decimal place. All right, so let's use this as a model. And let's look at number 4. All right, so Hudson invests $650 in a bank account that is paying an interest rate of 5% compounded continuously. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach $1,220? All right, so this one's a little different from the one before because we're not given the formula. But this is the formula you should know from last week. Compounded continuously is the formula A equals P E to the RT. All right, so P is the initial amount, A is the final amount, E is a constant, R is the rate as a decimal, and T is time in years. All right, so let's start off by plugging things in. So I'm starting with $650, so I know that has to go in my P spot. E stays, because E is the number. My rate is 5%. So I have to change 5% to a decimal by locating the decimal and then scooping it twice. Okay. Now this is the other number they gave me, $1,220. This is my final balance. But if you're not sure and you get confused, it's definitely not a time value. So it's not going to go in the T spot. So the only other spot it can go is in the A spot. All right, so in this question, I'm solving for a variable that is stuck in an exponent. So I know that I have to use a logarithm to solve for this. Now, key to using the logarithm is the base has to be isolated. This is the base here. That 650 cannot be there. The E, the base, has to be by itself. The 650 is connected by multiplication. So to take it off, I'm going to divide by 650. So I have $1,220 divided by 650. And I'm going to leave my number on the screen, but I get 1.8769230077 equals E to the 0.05t. All right, so now I have to use a logarithm to solve for t, because I need t to get unstuck from the exponent. So to do that, I'm going to introduce a log. Now, I can write the word log on both sides, but I can be more clever. Because I see the base of e, it would make more sense for me to use a base of e on this logarithm. So if I use a base of e for the logarithm, log base e is the same thing as ln. So I'm going to put an ln here. And I'm going to put an ln here. Okay, when I put the ln on both sides, that allows my exponent to escape, because the log, the ln, is the key to unlock the exponent. So that allows me to drop this in front of the ln. So I have ln of this crazy number equals 0.05 t ln of e. All right, now, if you're clever, you already know what ln e is, because ln and e are inverse of one another. But if you forget, that's okay. If you type ln and then type in the e, which is second divide, you'll notice it's 1. They're inverses. So this whole thing is just 1. So I have ln of 1.876923077 equals 0.05 t. I'm trying to get t by itself. So I divide 0.05 on both sides. And now I just type in this value. Alpha y equals, I have ln of 1.876923077. And if I was smart, I would have used second negative symbol to get my answer back in so I didn't have to type it or round it. So how long would it take to the nearest year for the value of the account to reach $1,220? So let me write my t value down. T is equal to 12.5926755. Okay, so to the nearest year, we have to be careful with this one. I want $1,220 in my account. So if I round down to 12, not that I would because of that decimal place, if I go down to 12, I wouldn't have enough money in my account. But even if this said 12.1, if I round down to 12, at 12 years, I would not have enough money in my account. So I have to round up to 13 years to have at least $1,220 in my account.